Next is direct current circuits or DC circuits or electromotive force and circuit. So for a conductor to have a steady current, it must be part of a part that forms a closed loop or complete circuit. So sa conductor, para magkaroon ng current, dapat meron siyang closed loop or complete circuit or daanan. In electric circuit, there must be a device in the loop that acts like a water pump. In this device, a charge travels from lower to higher potential energy. The influence that makes current to flow from lower to higher potential is called the electromotive force. So, na-discuss natin last chapter na ang EMF ay voltage. Ito yung source or pinagagalingan ng electricity. The SI unit of EMF is the same as that for potential. Volt is 1 joule per coulomb. A typical flashlight battery has an EMF of 1.5 volts. This means that the battery does 1.5 joule of work on every coulomb of charge that passes through it. We'll use the symbol. So, parang E yan, for EMF. Every complete circuit must include device that provides EMF. Such device is called the source of EMF. So, yung mga device na to ay pinanggagalingan ng electromotive force. Batteries, electric generator, solar cells, thermocouples, fuel cell are examples of source of EMF. All such devices convert energy of some form, mechanical, electrical, mechanical, chemical, thermal, into electric potential energy or electricity, and transfer it into the circuit to which the device is connected. An ideal source EMF maintains a constant potential difference between its terminal, independent of the current through it. So, ang maganda raw na EMF ay napapanatili niya yung voltage kahit na anong current ang kanyang dumaloy dito. We define electromotive force quantitatively as the magnitude of the potential difference. The increase in potential energy is just equal to the non-electrostatic work. So, work at point AB is equal to QE, that is equal to Q times volts, or work. Work is Q times B. So, the voltage at point AB is equal to E as a ideal source of EMF. From our equation in last chapter, the potential difference between the ends of the wire is given by V is equal to IR. And then combining this into our equation, so VAV is equal to E, and that is equal to IR. That is when a positive charge flows around the circuit, the potential rise E as it passes through the ideal source is numerically equal to the potential VAB is equal to IR as it passes through the remainder of the circuit. From our internal resistance, the potential difference across a real source in the circuit is not equal to the EMF. So, hindi siya equal. The reason is that charge moving through the material of any real source encounters resistance. So, nagkakaroon ng internal resistance ang ating battery. We call this an internal resistance. It stands for small letter R of source. As the current moves through internal resistance, it experiences an associated drop in the potential equal to IR. So, nagkakaroon ng voltage drop due to the internal resistance. Thus, when the circuit is flowing through a source from the negative terminal B to the positive terminal A, the potential difference VAB between the terminal is, so we have also here another formula, is equal to E minus IR. Di ba sabi natin that is equal to E but not equal because of this internal resistance, so that is minus. The potential VAB called the terminal voltage. So that is B sub T, terminal voltage, is less than EMF because of the term IR representing the potential drop across the internal resistance R. The current in the external circuit connected to the source terminals A and B is still determined by VAB is equal to IR. Combining this equation with equation 7.10, we get, so E minus IR is equal to E all over R plus R. Yan, ang formula natin. So, for equation 4. Next is example 8.1. A battery with E is equal to 12 volts. So, that is EMF. And internal resistance of 2 ohms. Is connected with external resistance. So, big letter R naman yun. Pag external resistance or load, big letter R. Pag internal resistance, small letter R. Find the current in the circuit. So, required A, I, or current. Letter B, the voltage drop, the voltage across the terminal, V sub T. C, the voltage across the 6 ohm resistor, B at 6 ohms. Letter D, kung meron pa, the power loss in the battery due to internal resistance. And E, the power delivered to the 6 ohm resistor and the power generated by the battery. Ang daming tanong ha. So, P, Gen. Now, for letter A, we have a formula for I. I is equal to E all over R plus R. So, from here, ano? Yan. So, EMF is 12 all over, external is 6 plus internal is 2. So, 12 over 8 is 1.5 amperes. Letter B. B total. The formula for B total is E minus IR. So, E is 12 minus current is 1.5 and then for internal resistance is 2. So, 12 minus 3 is 9 volts. Box. Final answer for every corresponding letters. Letter C. So, V sub R. V sub R is equal to IR from Ohm's law. So, the current is 1.5 times the resistance is 6. So, we have also 9 volts. For letter D, the P loss is equal to I squared R. Kasi yun ang hinahanap due to internal resistance sa R. So, 1.5 square times 2 is 4.5 watts. Letter E, P at R or power at 6 ohm resistor is, of course, this time I squared big letter R. So, 1.5 square times 6 equals 13.5 watts. Now, for letter F, the power generated is equal to P loss plus P sub R. So, kumbaga yung total power na nag-generate ng battery ay internal plus external power. So, that is 4.5 plus 13.5 is equal to 18 watts. Or pwede rin na I times E. So, kung dati I times B yung power, ngayon I E. Kasi nga, less than yung V kaysa sa E. Because of internal resistance. So, the current is 1.5. The EMF is 12. So, 1.5 times 12 is still 18 watts. So, kahit alin dyan ang gamiting formula, tama, no? So that is for example 8.1. Continue. Resistor in series. So we have here a figure for 3 resistors connected in series. So label as R1, R2, and R3, and for the total voltage or EMF. If the resistors are in series as shown in figure, the current I must be the same in all of them as in equal to the circuit current. So for our figure, 3 resistors are connected in series. The potential difference VAB across the entire combination is the sum of these individual potential differences. So ang B total is B1 plus B2 plus up to B sub N. So ang voltage pinag-a-add at ang current ay equal. I total is equal to I sub 1 is equal to I sub 2 up to I sub N. At ang total resistance ay pinag-a-add pag naka-series. So, yan ang formula or characteristics for resistor in series. Let's have an example. 3 resistors for R1 is 100, R2 is 200, and R3 is 300 are connected in series with total voltage of 30 volts. So find letter A, total resistance, B, the total current in the circuit, letter C, the voltage across in each resistor, V in each, letter D, the current in each resistor, so I in each, letter E, the power dissipated in each resistor or P in each, and letter F is the total power in the circuit. So for letter A, R total equals R1 plus R2 plus R3. So pinag-a-add ang current pag naka-series. So we have 100 plus 200 plus 300 equals 600 ohms. Letter B, I total equals B total over R total from Ohm's law. So B total is 30 all over 600. That is 0.05 ampere. Let's check. So 30 divided by 600 is 0.05 ampere or 50 milliampere. Letter C, the voltage. So since una muna natin masosolve yung D dahil I total equals I sub 1 equals I sub 2 equals I sub 3. Dahil pag naka-series equal ang current, and that is 50 milliampere. Now we can solve now for letter C. B sub 1 is I sub 1 R sub 1. So 50 times 10 raised to negative 3 times 100. For B sub 2, I2 R2, we can use 50 milliampere as 0.05 ampere times 200. So mamaya na natin computein. I3 R3, 0.05 or 50 milliampere times 300 equals, so 50 exponent negative 3 times 100, 5 volts, and this is 10 volts, and this is 15 volts. Now to check, pag pinag-add natin to, that is 30 volts. That is equal to V1 plus V2 plus V3, and that is equal to the total voltage. Now let's box. Letter D, meron na. Letter E. So for letter E, the power. Okay, maraming formula ng power. So current times the voltage, that is 0.05. Voltage 1 is 5. 0.05 times 5 is 0.25 watts. Pwede rin na ang power is I squared R. Pwede rin na B squared over R. So kahit aling formula ang gamitin, basta tama ang sagot. And 5 square over 100. So let's check. 0.05 square times 100. 0.25 watt. And this is also 0.25 watt. So 25 divided by 100. So for P2, ang gamitin na lang natin is I2 B2. So 0.05 equal current pag naka-series, voltage 2 is 200, no? 10. So that is 0.5 watt. And for P3, I3 B3, 0.05 times 15 is 0.75 watt. Box. And for P total, letter F. P total is I total B total, I total squared R total, or B total squared over R total. Isa lang answer niyan. We have 1.5 watts. Or ang power ay pinag-a-add kahit naka-series or parallel. So 0.25 plus 0.5 plus 0.75 is 1.5 watts. So again, pag series, ang equal dito ay current, ang voltage pinag-a-add, ang total resistance ay pinag-a-add. Ang power naman, kahit naka-series or parallel, ay pinag-a-add. So next is resistor in parallel. For resistor in parallel, if the resistors are in parallel as shown in figure, potential difference between the terminals of each resistor must be the same and equal to Vt, meaning V total equals V1 equals V2 equals up to V sub n. Unlike sa series, ang voltage pinag-a-add. Dito sa parallel, equal. And the total current is the sum of each individual current in each resistor. And for total resistance, that is the reciprocal, sum of the reciprocal. So, reciprocal of the sum of the reciprocal. Plus up to 1 over R sub n. So, for any number of resistors in parallel, the reciprocal of the equivalent resistance equals the sum of the reciprocal of their individual resistances. So, para sa karagdagang information, ang mga appliances or ilaw natin sa bahay ay nakakonect in parallel para equal ang voltage. Lahat ay 220. At pag naputol yung ibang linya, yung ibang nakakabit ay gumagana pa rin, no? So, pagka series ang application niya is Christmas light. Pag naputol yung isa, putol na lahat. So, that is difference between series and parallel connection. So, for example, 3, the total current passed by a 300, 600, and 800 ohms connected in parallel is 200 milliampere. So, this time, hindi voltage ang given, kundi current. So, pag current, ang symbol niyan ay direction. Pag naman voltage, polarity, negative and positive. So, this is IT. Total current is 250 milliampere or 0.25 ampere. So, the resistors are 300 for R1. Papangalanan niyo yung mga resistor. 600 for R2. And 800 for R3. So, ang mga questions, letter A, R total. Equivalent resistance of the circuit. Letter B, the line voltage V total, letter C. The current in each branch, I in each. Letter D, the power consumed, P in each. And letter E, P in each. Letter D, P in each, and then letter E, power dissipated by the circuit or P total. So for the solution, letter A, R total is the reciprocal of the sum of the reciprocal. 1 over 300 plus 1 over 600 plus 1 over 800. So equals, so pagka parallel, ang resistance ay lumiliit, no? Mas maliit pa sa pinakamaliit na nakakonect in parallel. So that is 160 ohms. Ulitin natin. 300 reciprocal plus 600 reciprocal plus 800 reciprocal. And then reciprocal is 160 ohms. Box for letter A. Pagka naman series, ang resistor ay tumataas, ano? Di ba? So pinagaan. Dito, reciprocal of the sum of the reciprocal. And the total voltage from Ohm's law is I total R total. So for 250 milliampere, that is 4.25 times 160. So the voltage is 0.25 times 160. 40 volts. Letter C, the current in each. So I sub 1. Now, our 40 volts is equal to B total equals B1 equals B2 equals B3. Dahil parallel equal ang voltage. For I sub 1, that is B1 over R1. So 40 over 300. I sub 2. B2 over R2, 40 over 600, and for I sub 3 is B3 over R3, 40 over 800, so I3 is 0.05 ampere, 40 divided by 800, and then 40 divided by 300, 0.133 ampere, 40 divided 600, 0.0667 ampere. So 3 decimal places, 3 significant digit. Minimum. Box. Letter D. Okay, check. Add natin. So 0.133 plus 0.0667 plus 0.05, is that equal to 25 milliampere or 0.25 ampere? Kasi ang characteristics ng resistor in parallel ay pinag-a-add ang current. So 0.133 plus 0.0667 plus 0.05 is 24.2497, almost equal to 0.25 ampere. Check. Letter D, the power, current times the voltage na lang, pero maraming formula, I squared R or B squared over R. No? So the current 1 is 0.133, voltage 1 is 40, power 2 is I2B2, 0.0667 times 40, and for P3, I3B3, 0.05 times 40. So 0.133 times 40, 5.32 watts. 0.0667 times 40, 2.668 watts. And 0.05 times 40 is 2 watts. Box for individual power. Now, for letter A, B, C, D, E, P total is Sabi ko, kahit naka-series or parallel, pinag-a-add. So, P1 plus P2 plus P3 is 5.32 plus 2.668 plus 2. So, 4.668 plus 5.32 is 9.988 watts for P total. Or, pwedeng I total squared R total, pwedeng I times B. So, I have here, the total current is 0.25 square times 160 for R total. So, 0.25 square times 160. 10. Almost 10 watts. Okay? Or current is 0.25 times the voltage is 40 rather. So, that is 10 watts. Or pwede rin na V square over R. That is also 10 watts. You can try, ano? So, kahit maraming box, basta isang value, okay lang. No? So, that is for direct current circuit or DC circuit part 1. The coverage are EMF, resistor in series, and resistor in parallel. So, for next meeting, we discuss for the combinations of resistor or series parallel or parallel series resistor. Kasi mahaba yun no?